Greetings, everyone. We're from Group 6, and today we're going to present to you our findings and result in case study 4 about warehouse inventory management in food and beverage. So beforehand, we introduce ourselves. My name is Muhammad Rizqi Naufal with NPM 23061722224.
My name is Alisha Zafira.
My name is Elangga Mudhofar.
My name is Mechra Habiel Azzikra.
My name is Monika, Dewi, Angelina.
And my name is Nadine Anindya Putri. Okay, to start, our background is a large warehouse struggles to manage its inventory efficiently, leading to overstocking, stock out, and increase operational costs. So what we need to do is create a system that dynamically adjusts inventory placement and robot routing based on real-time order data. But we should consider this 4 point. Next. Okay, this is our key patterns that we are observe. Next. And this is our flow chart.
Okay, first, we collect items in the inventory by this block of code where it collects inventory item data using user input. And the function we use in this code are feature structure input, dynamic zone allocation, stores each item in directory, batch friendly input, and also built-in expiration alert.
Okay, move to the shelf life of product. So this function is used to check if a product is about to expire soon based on the shelf life written in weeks. And the function explanation, there are terms everything lowercase and look for the word week. And next is try to get the number and check how many weeks are left. If it's 4 weeks or less, it returns soon expiring. But if it's more than 4 weeks, so it's okay. And we should handles word inputs. And if it's not in weeks at all, it's also returns okay by default. Next.
Next is the seasonal analysis. This process takes historical monthly sales data of products, computing it and showing how each month's demand deviates from the average with the seasonal index, which is Q per average, and helping us to indicate if there is shortages. Next.
Next, we make the codes for the robot delivery speed, where it identifies the shortest path from the starting zone, accounts for any traffic slowdown, and also computes the total time using the robot speed. And the function we use are lists to define a fixed zone, set compression to collect assigned zones, sorting to order the route, loop to iterate through each zone, tuple to represent zone pairs, dictionary to store traffic vectors, and also arithmetic to calculate total distance and convert it to delivery time.
Okay, so robot routing is used to simulate a robot delivery system in a warehouse or a similar setting where a robot starts at a parking location and is assigned to delivery or pick up an item from a specific zone A, B, C, or D. So this Python script simulates a robot delivery system where a robot starts from a parking zone and delivery or pick up item from design zone. The get of the robot path zone function calculate the round trip path from parking to the specific zone and back, while simulate robot delivery system process an item by checking its assigned zone. And it helps with an appropriate message. The script effectively models a simple routing and distance tracking logic for a warehouse automation. Next.
So this block of code simulates robot delivery for each time, performs seasonal demand analysis to detect potential shortages, and calculate restocking costs based on user inputs. It then computes the total delivery distance using robot speed and zone layout, prompts for the operational costs per meter, and calculates the overall delivery cost, also the total operational cost.
And then we use the code item in items to create a looping, seasonal analysis to call the seasonal analysis function, calculate restocking cost item to calculate the restocking cost from the list called items, and also the distance to actually calculate the robot delivery speed. Next.
Okay, so for the last one is total operational cost. This part of the program calculates how much it costs for a robot to deliver products across different storage zones in a warehouse. And for the function explanation, first one is the robot travel distance. So the program runs to calculate robot delivery speed function to find out how far the robot travels in total. And then user input, we ask to enter the cost per meter of robot movement in Indonesian rupiah. And next, they will calculate the cost calculation. So for the conclusion,
So, in conclusion, this project uses computational thinking principles to optimize F&B warehouse inventory management. The algorithmic solution implemented also included dynamic zone allocation based on availability and expiration risk, seasonal sales index calculation to anticipate shortage, robot route optimization, counting for traffic slowdowns, restocking, and operational cost calculation to improve decision making. So, structure problem solving. The team applied decomposition, pattern recognition, and abstraction to break down and understand warehouse inefficiencies.
Also use algorithmic optimization and we use gradient brute force to help with the decision making in zone assignment, self checking, shelf life checking, seasonal analysis, and robot routing, which leads to a more efficient systematic operation. And we improve operational efficiency by integrating real time data and dynamic adjustment. Next. And that concludes our presentation of case study 4. Thank you for listening and see you in another occasion. Thank you.